Hey guys, welcome back to the Workplace Apprenticeship 20 videos. In this video, we're going to look at Lesson 3 from Chapter 3, which is talking about volume and capacity of prisms and cylinders. So the volume of an object is the measure of the amount of space it occupies, while on the other hand, your capacity of an object is how much it can hold. So all objects will have a volume, but not all objects will have a capacity. So it really depends on what type of object you're dealing with. Say, for example, if you had hollow objects, maybe like a cardboard box or maybe even a pizza box, that would have a volume and capacity because it takes up space and you can also store something in it. And then on the other hand, solid objects, maybe like a cement brick, would only have a volume. You can't actually store anything inside that cement brick, so we would say it does not have a capacity. So in terms of talking about your units, your volume is measured in cubed units. Say, for example, we had meters cubed here. And then your capacity, on the other hand, is measured in units like liters or gallons. And in our course, we're really only going to work with liters for now. So volume and capacity are closely related. In the metric system, we know that a volume that is 1,000 centimeters cubed is equivalent to 1 liter. So if you're in science, maybe science 10, you guys might recognize this type of conversion. If not, hopefully throughout this lesson and throughout the course, you guys will start to get a little bit more comfortable with converting between volume and capacity. So this here is really important because this tells us a rate, which is really important for when we're trying to convert from volume to capacity, or even going backwards from capacity to volume. So this tells us that for every 1,000 centimeters cubed, that is equivalent to 1 liter. This will be important a little bit later on in this video. So the volume of both a prism and a cylinder are found in the exact same way. So we multiply the area of the base by the height of the object. So we're using this exact same formula for each of your types of objects, for both prisms and cylinders. So where this differs is really in the area of that base, because we know with cylinders, that's going to be the area of a circle, whereas your prism might either be a rectangle or a square. But otherwise, this exact same formula for volume will be used for prism and cylinder. So suppose we know our volume and we were asked to find our capacity. Our first step here is we have to make sure our volume is in centimeters cubed. That's really important because remember that rate that we discussed earlier is talking about centimeters cubed compared to liters. So my recommendation, if you're not given centimeters and you're asked later on to find your capacity, my #1 recommendation is to find your volume in centimeters cubed first. So step #1 is convert to centimeters before finding, say, your volume. So say if you're working with meters, you don't want to be working with meters cubed. It's a gross type of, I guess, conversion. It is possible. I would just not recommend it though, okay? So anyways, so first make sure that you're working with centimeters cubed, and then all you do is you just divide that volume by 1,000. Then your new liter or units become liters. And if you're asking where this comes from, so how do you know to divide by 1,000? Well, that one there we can just look at unit analysis. So let's just shoot out an example. So suppose we had a volume of 21,000 centimeters cubed. So using that rate that we had above, we know that there are 1 liter for every 1,000 centimeters cubed. If you're trying to work out this math, write this over 1 and then just multiply across. And what we'd essentially find is that we'd have our volume, so 21,000 divided by 1,000. And we'd find that we'd have a capacity of 21 liters. So essentially all that we're doing is we're taking that volume and dividing it by 1,000. So either if you guys want to just remember or memorize that you have to divide by 1,000, or if you prefer that unit analysis, either way it'll get you to the same answer, okay? So now let's apply all this information to some examples. And the examples that we're going to look at is question number 2 from your notes. So a can of tomato sauce has a radius of 3.8 centimeters and a height of 10.2 centimeters. So we want to know what is the volume of the can. So if you're having troubles with this, my first recommendation is even just draw this scenario. Well, what does a can of tomato sauce look like? Well, those are typically in a cylinder. So start off by drawing a cylinder. This is my wonderful drawing. I should have been an artist. And we know that it has a radius of 3.8 centimeters. So I'm going to draw that right from the middle going out to the edge of the can. That was 3.8 centimeters. And we know that the can has a height of 10.2 centimeters. So we could say h is equal to 10.2 centimeters. Now that we might have a little bit clearer idea of what's going on, now we can actually go into solving for the volume of the can. So start off by writing your formula. So your volume is equal to the area of your base times it by the height. Now in this case here, we're working with a cylinder, which means that our area of our base is going to be a circle. So we're going to replace the area of your base with the formula for the area of a circle, which in that case is pi r squared. Then we're going to multiply that with your height. Then we can fill in all the information that we know. So we know our radius, we know our height, and pi is just a symbol for a number, so we're just going to leave that as pi. So you have pi times your radius, which is 3.8 squared, times it by your height, which is 10.2. And at this point here, you guys can go ahead and put all of this into your calculator. So just be very careful with how you're putting it in. Make sure you use the actual pi symbol, not just the shortcut 3.14. And then be careful with your brackets. Make sure you're scoring the 3.8 and then not your answer of pi times 3.8. So where you see brackets here in my example here, make sure that that's where you put your brackets in your calculator, okay? So once you put that in there, you would find that this can has a volume of 462.72 centimeters cubed. So remember here we have our units of centimeters, so our units cubed is our would be for volume. This is also a word problem, so make sure you answer it with a sentence. So you could say the can of tomato sauce has a volume of 462.72 centimeters cubed. Once you've got that, we're ready to move on to part B. So part B here wants to know how much tomato sauce in liters does the can hold. So if you guys remember earlier in the video, we said that your capacity was equal to your volume divided by 1,000. And that's assuming that this volume here is in centimeters cubed, which in this case it was, so we don't have any work to go back and redo. So in part A, our volume here was 462.72 centimeters cubed, and we're going to divide it by 1,000. You can either put that into your calculator, or as you guys know, if you guys remember that little trick for dividing by multiples of 10. For dividing, we're just going to move our decimal 3 times to the left, so the same number as we see zeros on the bottom. And so we get 0.46272 liters as our answer. But we should always round to 2 decimals, as I prefer. And to 2 decimals is 0.46, and we don't have to worry about rounding because that number here is a 2. So our answer here is 4.6 liters. Then just to finalize this answer here, just make sure you write a sentence. So you could say the capacity of the can of tomato sauce is 0.46 liters. So when you're all done that, you've fully completed this question, and then you guys are ready to move on. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.